Thank you. So yeah, uh, reporting messages. Then there was destination unreachable is a category. This is the format. So there is a type, code, checksum, unused, and there are few IP headers and datagrams. So type will tell you what kind of problem there is. Code will tell you exactly what. So if there is, for example, type 3, it says that it is a destination unreachable problem. Then code will tell you why. Maybe the link is down, the machine is broken, or there is no connection or something like that. Okay. I will, I think when I send you the PPT, this Word document won't come, but this is, I will send it to you separately. Okay. So for example, under destination unreachable, if the code is 0, then there is the possibility of hardware failure. So something hardware has failed. That is why it is not reachable. Then there is a possible, this is network unreachable. If it is code 1, it is host unreachable. Okay. So like that, there are different problems which will be reported, which will be stated with the help of type and code. Then we did source quench, time exceeded, parameter problem, and redirection. And then we ended up here. Okay. Next. So query messages. Now we have finished with this type, error reporting messages. Now we are on query messages. Query messages are further divided into two categories. One is echo request and reply. The other is time request and reply. Echo request and reply is the ping thing. When you say ping some machine and you echo it and you get a reply, so that is echo request and reply. Timestamp request and reply, we'll see. Okay. So query messages are for identifying network problems. Earlier, there were 5 query messages, among which 3 are deprecated. Deprecated means no longer used. They are archived. Okay. These are the two remaining: echo request and reply, timestamp request and reply. So query messages, echo request and reply. When echo request and reply messages are exchanged from one host or a router to another host or a router, it's or routers can communicate with each other. So from one host to router, or router or router, or between the two. Okay. So again, type 8 or 0, code 0, and so on. Okay. We are not going to go deeper into the types or what those codes are. Just for example, I have shown you here for destination unreachable how they are different. If you want to, you can go deeper on your own by checking what each type means, what message it will send, or what error it will report. But for now, just understanding the format and what how many types or codes there are, we are good. Okay. So it confirms that the two hosts or routers can communicate with each other. If a host or a router wants to communicate with another host or a router, which means it can go between host to host or host to router. Okay. Then it sends the echo request message to corresponding host or router with which it wants to communicate. The host or router receives the echo request message, prepares an echo reply message, and sends it to the original sender, confirming that is ready to communicate. So basic example is the ping message. When you say ping an IP address, it sends you a reply. You are sending an echo request and you get the reply. For example, I will send a random IP address. So this is the echo request and this is the reply. The request timed out. Okay. This is the ICMP v4 message has given you a reply and reported a problem, and the problem is request gets timed out. Okay, timestamp request and reply. Timestamp request and reply messages calculate the round trip time. It is the time required by an IP datagram To travel between two hosts or routers, this pair of messages are also used for synchronizing the clocks of two machines, hosts, or routers. Okay. Again, uh, so the clocks, okay, this synchronizing the clocks of two machines is very important. And by clocks, I don't mean the CPU time clocks. I mean literally the time that is here, 9:55 or so. So the time on my machine and the router or a server that you're connecting to needs to be exactly the same. If it is not, there are many problems that you can run into. Again, this comes under the scope of information security subject or further down in networks. Currently not in our scope, but if you want to go ahead, you can go ahead and research on your own why synchronization of clocks is important, why two machines need to be on the same time frame. Okay, next. So there are only two types. One is request, one is reply. Code is only one, which is 0. And then we have an identifier, sequence number, original timestamp, receive timestamp, transmit timestamp. The reason why we have this is, suppose I am on a different timestamp and my router or another host that I'm communicating to is on different timestamp, then the original timestamp will be there. The server will send a receive timestamp, we will transmit, and we will be on the same timeline. So for example, I am on 9:56, server is on 10 o'clock, we communicate, I receive the timestamp, my timing automatically changes to 10, and then we start communicating. Okay. Then, okay, if you want to go to this is the RFC. I hope you guys remember what RFCs are. This is the paper written and internet governance accepted worldwide protocols. Okay. The original data and how it is set up is all here. You can go and check it. Okay. Next. So key takeaways. ICMPv4 protocol is a network layer protocol. This protocol is error reporting, reports error that occurs while IP datagram travels from the source host to destination. ICMPv4 is a message-oriented protocol that is used in assistance with IP protocol, as IP protocol lack error reporting. Okay. IP protocol is another protocol rule which is followed. ICMPv4 is used in assistance with it because IP protocol, okay, the name itself is IP, does not have the ability to report errors. Okay. IP datagram encapsulates ICMPv4 message before passing it to the data link layer. I hope you remember the OSI model. It is only responsible for reporting the error. It does not correct the error. Okay. So the request timed out is only that I got when I did a ping so and so IP is only the reporting of the error. It does not rectify or correct the error. I myself have to find out why request timed out. In this case, since I'm at home, I used a made up IP address. I got that error. So I know that obviously something is made up, something does not exist. That is why the error. But when you're in a company or in a proper network, there will be some other problems which you will have to rectify on your own. The only thing an ICMPv4 message will do is report the error. Okay. ICMPv4 is classified into two types of error messages and query messages, which are further classified as you have seen above. Any doubts so far? I know it was theory, kind of boring, but any doubts? Okay. Next topic, mobile IP. So Mobile IP or MIP is an Internet Engineering Task Force. Again, RFC is given. You can check the original research data, original agreed upon worldwide rules and protocols, formats for the mobile IP. De facto standard communication protocol. It is created by extending Internet Protocol IP. The mobile IP allows mobile device users to move from one network to another while maintaining the same permanent IP address. So this is very important. The mobile IP allows mobile devices users to move from one network to another while maintaining the same permanent IP address. Can you think of an example?
Mobile data to router.
Mobile data to router, but you are still in the same network. Okay. A simple example would be suppose your phone is dual SIM. You have Geo and you have Airtel, for example. Now, these companies, when they provide you internet services, the IP addresses, both have a different set, right? The companies buy different IP addresses. Right. Port.
But sir, it's like every time we use the internet, we get different IP addresses every time.
That's dynamic IP address. But when you change, suppose we are calling someone and you change the um, network, your IP remains the same. So what I mean by that is, for example, okay. So now air, okay, this is good, right? So we have Airtel and we have Geo. Okay, so these companies buy certain blocks of IP addresses. Okay, so this is a block of IP addresses. Hmm. Now let's say this is from 1 to 100. Again, you assume the IPv4 format. Okay, I'm just giving you an example, and they buy from 200 to 300. Now, when you connect to the internet, either via Geo or Airtel, you are dynamically assigned an IPv4 address. Yes, you are correct that this changes every time you change the, sorry, you are connected to the internet. They are providing you the internet services, so they become your ISPs and they give you an IP from one of these, from this block. Okay, now assuming that you make a connection, you change network. Let's say you go from, so when you connected to the internet, you were using Airtel, but you make a call from Geo. Okay, the call goes over Wi-Fi calling. Okay, or volt technology. Okay, it goes over that. As soon as you do that, your network changes. Now, what the mobile IP feature is, instead of making the infrastructure change of changing the IP from one block to another, it keeps it as it is. So when you switched on your phone, you connected to Airtel, you got an internet, and he gave you an ID of 57. So this remains even when you are connected to Geo, you move to Geo or make a call from Geo. So that's what mobile IP does. Okay, this is an overview. It gets messier as you go deeper. So, but again, not in our scope, just get the idea. Okay. In IP networks, when a device is within its home network, the routing is based on static IP addresses. The device within a network is connected through normal IP routing by the IP address assigned on the network. It is the same as how a postal letter is delivered to the fixed address on the envelope. The problem occurs when a device goes away from its home network and is no longer reachable using normal IP routing. In this condition, the active sessions of the device are terminated. The idea of mobile IP was introduced to resolve this issue. It facilitates user to keep the same IP address while going to a different network or a different wireless operator without being communication disrupted or without sessions or connections being dropped. Again, another example would be if you have Netflix on your phone, start it with an Wi-Fi. Then after Wi-Fi, switch off the Wi-Fi and let your mobile data start. So your Netflix session, whatever you're watching, will not be disconnected. Your connection will keep on going. The movie, the series, or whatever you're watching, it continues to work. Your IP does not change. You have changed the network from Wi-Fi to your phone. You have changed from your Wi-Fi provider. Suppose Hathway, you go from Hathway to Idea or Geo or Airtel or whatever you use. So your network has switched, but your IP has remained same and your Netflix session has not terminated. That is the whole idea of mobile IP. Okay. The mobility function of the mobile IP is performed on the network layer rather than the physical layer. Okay. If it was physical layer, the wireless connections, as in it would not have worked on Wi-Fi. So naturally, it works on the network layer. Okay, that's it for mobile IP. We are not going to dive in deeper. Next, unicast routing protocols. Unicast routing protocols are okay. Let me see how many. Four. Okay, we'll just go through these four more slides. I'll go through the theory, and next time, hopefully, when others are there, uh, we'll go through the working and the next what do you say uh, protocols and routing protocols. So next time it would be irrespective of everyone is there or not, but I would like to give some time, one more week to see if everyone is there, uh, and otherwise we'll just move ahead and finish unit 1. Okay. Okay, just to give you an idea, this is the last part of unit 1. Unit 2 has already started by Sumit sir. He took a few topics. We will go through those topics also, but we will go a little bit fast with them. Okay, right. So unicast routing protocols are used to route data packets to a single specific destination on a network, one-to-one communication. Okay, categories. I think I missed categories. Never mind. Distance vector protocols. It uses algorithms that calculate the best path based on the number of hops. Example, RIP, IGRP. So these are unicast protocols. What do? They use algorithms which calculate the best path. They can depend on hops or speed or distance, all these things. Okay, based on that, they choose the best path for transferring data. Then we have link state protocols. Oh, sorry, these are the categories. My bad. So categories are distance vector protocols, link state protocols, path vector protocols. Okay. So distance is calculates the base path based on the number of hops. I hope you remember what hops are. One router to next router is one hop. Okay. Router to router only, not machine to machine, not computer to computer. Okay. And it works on the across. Routers are used for across networks from one network to another network, not within the network. Okay. Link state protocols. Each router builds a map of the network and determines the shortest path. OSPF, IS, okay. Okay. So these are link state protocols. So there is one which is so one is distance vector protocol. Okay. उसमें है RIP, IGRP, and so. Like I said, this is a router, this is a router. This is -1 hop when data transfer from here to here. Now suppose this is a network. Okay. Okay, this is router 1, router 2, router 3, router 4, and so on. Okay, never mind, I'll just. So what distance vector protocol does is it counts the hop, and based on that, best path is selected. So now, okay, we have learned this has been done. So tell me, based on hop count from PC1 to PC2, how will the message go? And tell me what is the cost of each path. I'll give you an, no, I can't give you an example. It will just give you an answer. Yeah, you have given the paper, you have done it before. Tell me. Okay, so path 1. Okay, this is part 2 and path 3. What is the cost of each path? And if a message wants to go from PC1 to PC2, how will it go? I have already told you how it will go. The algorithm states that based on hop count, the path is chosen. The best path is the one with the least hop count. Okay, this is the answer. So tell me, how will it go? I hope you remember what hop count is.
The path 2.
Mhm. Sorry. Yeah, sorry. I opened to know who answered.
It's me.
Yeah. Okay, Momita. Thanks. Yeah, you are correct. It's part 2. So why part 2? What was the cost of this in number of hops?
The 2 hop.
Yeah. Okay. So minus 1, that is 2 hops. This is minus 1, minus 1, minus 1, which is 3 hops. Our algorithm chooses the least hops because that is the shortest path. The shortest path is the best path. Therefore, the message goes from this router to this router to this router. So message goes from R1 to R6 to R4. Okay, correct. That's great. Next, similarly, there is link state protocol. Each router builds a map of the network and determines the shortest path. He will build a network. So suppose like this, like this, like this, or like this and like this and like this, something like this is the name. So he will figure out from where to where the message is to be sent and which is the best path. यहाँ से भेजना है, or do I need to send it from here, or basically which path, or it goes from here then down here and up there. Okay, so first it will say that this, this blue is network map 1, this red is network map 2, this green is network map 3. Okay, network map 3. Now among network map 1, 2, 3, which is the best, it sees that red is the best, and so the message is sent from here to here. This is what link state protocols do. As examples further ahead, we will see RIP and OSPF. Okay. Next, path vector protocols maintain path information typically used in large scale networks, which is BGP. BGP is border gateway protocol. Large networks means super large networks, like sending from, assume that Pune city is one network and we are sending it to Mumbai city, which is another network. Okay, so you have to maintain the path information, and based on that, path vector protocols are used. The problem occurs when there are changes, so that is why this protocol is important, and it needs, the protocol is important, and that is why we use it, because we need to understand the path. So if there is a change anywhere in between, only that portion is rectified and another path. So from, let's say path is A, B, C, D and B, C broke, the points between B and C broke. So what we'll do, A to B to jayega he, and he knows that C to D jana hai. So beach mein somewhere he will find a alternative route. Okay. So examples, yeah. So examples are RIP, Routing Information Protocol, OSPF, Open Shortest Path First, BGP, Border Gateway Protocol. We will see the working of each of these and as well as the theory part of each of these. Key characteristics: efficient data transmission to one device, often used in LANs and WANs. LANs is local area network, WANs is wide area network. Local area network is, for example, your home network, your building network. Wide area networks will be something that goes from one location to another. For example, a certain area. For example, Mumbai's ka Andheri to Mumbai ka Churchgate. Okay, that's a wide area network. Routing information protocol. Again, we'll quickly go through the theory part and I will show you tomorrow how it works or how it is given. Again, that is a very short thing. Another, I need each of you to make an account on this. Okay. Download Cisco Packet Tracer, complete whatever authentication or account creation procedures are. Okay. Make your account, make sure that you have this application downloaded on your laptop or wherever you want it, but you need to have an account on this. There will be certain labs or certain demonstrations that I will ask you to do on this Cisco Packet Tracer. So make sure you have it in your system. You have 1 week. I hope so that next week you have it ready. Don't worry, not that I am going to give you an assignment immediately. So, routing information protocol. So it is a dynamic routing protocol that uses hop count as a routing metric to find the best path between the source and the destination network. The example that we just saw. Okay. So we have three paths. The best one was this one because its hop count was 2. This was 3. So this takes shorter time, shorter path, which is the best path. And hence the message goes from PC1 to PC2 via the route R1, R6, R4, which is this middle route. Okay. It is a distance vector routing protocol. Distance vector, right? It calculated the distance. Obviously when I say distance, nobody is going to go and measure the wire or the distance between one point to another. ऐसे तो possible है नहीं, right? There we need to somehow find a way to calculate the distance online. So I hope that is clear. That has an administrative distance value of 120 and works on the network layer of the OSI model. RIP uses port number 520. I hope you know what port numbers are. If you don't know, go to Google and search it. This won't be explained here. Then administrative distance value of 120 is kind of like the default. So when beach mein we did this ping, right, and it said request timed out. Okay, if you give random, yeah, it's okay. This is on network. Strange. Never mind. Okay, this is on network as well. Yeah, request timed out. So this happens because it crossed 120. Okay, the 120 hop count was crossed. That is why request timed out. So it is like the default here. So it went from one router to the next, to the next, to the next, and keep going on, and it didn't find anything. It went to 120 distance, 120 routers it crossed. It did not find anything, and hence the result That request timed out. We didn't find anything. Sorry. Right. Next, hop count. It's the number of routers occurring between the source and the destination network. Again, I've told you what it is. You can go through it again on Google or when I send you the PPT. Okay. The maximum hop count allowed for RIP is 15 and a hop count of 16 is considered as network unreachable. Okay. So default hop count is 16. If it crosses 16, we have network unreachable. This administrative distance is by default and probably would you would get it in a company or something like that. But for your home network or something that is done on a personal level, your RIP, the hop count for RIP, this protocol is 15. This is 120 is in general. Okay, not for this particular routing. Features, updates of the network are exchanged periodically. Updates, routing information are always broadcast. Full routing tables are sent in updates. Routers always trust routing information received from neighbor routers. This is also known as routing on rumors. There are three versions of routing information protocol: RIP version 1, RIP version 2, and RIP NG. Okay? Updates or the network are exchanged periodically. Network updates matlab ye whatever this paths and the router. So for example, R1 is connected to R2 is connected to R3 is connected to R4. This is one path, and updates of these paths are exchanged periodically after every 10 seconds, 1 minute, whatever. Okay, these are always broadcast. It means that this path, okay, is broadcasted to everyone. So right now this is PC1, but let's say this PC2 is also connected, PC3 is connected, 100 PCs are connected over here. Okay, sorry, let's say 100, where's my, yeah, 100 PCs are connected in this network. Okay, in this network. So the update that R1 is connected to R2 is connected to R3 is connected to R4. This is one path. This path updates are sent to all these 100 PCs. And how are they sent to these 100 PCs? Via broadcast messages. If I want to send a broadcast message, what IP do I need? This path message or this path, I want to make every PC aware of this path. Now, since I want to make it aware, every PC aware of this path, I'm going to send a broadcast message. Where should I send that broadcast message? On which IPv4 address should I send that broadcast address? Sorry, broadcast message. I just told you the answer. Guys, where will I send the broadcast message? On what IP address will I send the broadcast message? Did you guys sleep? Should we stop? Okay, let's stop. We're done. RIPv1 is known as classful routing protocol because it doesn't send information of subnet mask in its routing update. R2 is known as classless routing protocol because it sends information to subnet mask in its routing update. You can check on your own or when I give you the PPT. All right, that's it. Pratiksha, please send your email address, whichever, I mean, there's no specific, send whichever you want, and I will give you access to the previous recordings. Okay?
Okay, so send check chat box.
Chat box. Just a minute. Hmm.
Okay, I will
Yes.
send in
Yeah,
WhatsApp.
got it. No, got
Got
it.
it?
Pratiksha Thange07@gmail.com, right?
Yes.
Yes. Thank you so much. Okay, I'll send you the links. So by Monday, you will have it. If for some reason you don't see it, you don't see my message, please do send me a reminder. Okay.
Okay, sir.
Thank you. All right, that's it for the lecture. Thank you, guys. See you next time.